All right, guys, so now we're going to transition into different ways to write the equation of a line. So you spent a lot of time talking about that slope intercept form, that thing like that looks like y is equal to mx plus b. But today we're going to talk about different ways to write an equation for a line if you have different pieces of information. So here's another one. An equation of a line can be written in what we call point slope form. We can write an equation in point slope form if we're given the coordinates of a known point on the line, as well as the slope of that line. Okay, so let's read what that says. An equation of a line can be written in point slope form given the coordinates of a known point on that line and the slope of that line. Okay, so if you have two ingredients, if you have a point and you have a slope, you can write an equation in point slope form. Okay, so what is the equation of point slope form? It follows this format. It follows the format of y minus y1 is equal to m times the quantity x minus x1. Okay, this is called point slope form. This is the equation for point slope form. It is a different way to write the equation of a line. So we've already talked about that y-intercept form, that formula most of you guys know at this point, y is equal to mx plus b. All this is down here is a different way to write the equation of a line. If we don't have an intercept, but we have one random point on that line, we're able to write an equation in point slope form. Okay, so let's take an example. It says, write an equation in point slope form for the line that passes through 3 comma negative 2 with a slope of 1/4. Then graph the equation. Okay, so we want to write our equation in point slope form. It's asking for us to write the equation of this line in this format. Y minus y1 is equal to m times x minus x1. Okay, a little bit more complicated looking formula, but it's still the same principle of plugging things in and seeing what you get back. Okay, so what are they giving us? They're giving us a point and they're giving us a slope. We have everything we need to write an equation in this format. Okay, so let's just plug these pieces into that formula. Okay, so when I'm doing this, I'm always going to start with y minus a number. And I'm going to subtract my y coordinate. And as you guys know, I'm going to look at this coordinate over here. I have x comma y. So I'm going to subtract negative 2, y minus y1. But instead of subtracting negative 2, I can just flip that to plus 2. And that's equal to m, which is my slope, 1/4, times the quantity, x, I'm always going to have an x here, minus x1. And this is my x coordinate, which is just 3. Okay? After you have your equation in this format, if it's asking for it in point slope form, you are done. You don't have to do anything else. This is the equation of a line in point slope form. It looks super ugly, but it's completely legal. Okay? It follows the format y minus y1 is equal to m times x minus x1. Okay, so now what we're going to do is we're just going to graph this. So how do you graph it? We're going to start by plotting the point 3 comma negative 2. And where is 3 comma negative 2? It's 3 units to the right, 1, 2, 3, and then 2 units down, 1, 2. This is my first point right here. Okay, but it's got a slope of 1/4. So what does that mean? My slope is I have to rise 1, run 4. Rise 1, run 4. So it's rise 1 over 4. 1, 2, 3, 4. The second point looks like it's off the page, but let's get one more coordinate that's actually on the grid. Instead of going up 1 over 4, I could also go down 1 and then over 4 to the left. 1, 2, 3, 4. I've got 3 different points, and I could easily connect these dots to get that line. A little bit ugly. But that's what my line looks like. if I have an equation in that format. Okay, let's do a different one. It says write an equation in point and slope form for a line that passes through 2, -1 and has a slope of -6. Okay, once again, it's asking for point slope form. The trickiest part of this is just remembering the formula. Keep writing it over and over again until you remember it. Y minus y1 is equal to m times x minus x1. Okay, always going to start with a y. You're going to subtract your y coordinate. This is x, this is y. Y is equal to -1, so instead of subtracting -1, I can just write +1 is equal to m. What's my slope? My slope is equal to -6. I'll have -6 for m. In parentheses, I'm always going to have an x, and then minus x1. x1 is equal to 2 minus 2. Once you have this, you are done. You have it in point slope form. Now, let's graph it. Start with the point they give you, 2, -1. So I'm going to go 2 units to the right, 1 unit down, right here. And then what's my slope? My slope is equal to -6. A different way to write that is -6/1. So how do I graph this? I would go 6 units down, 1, 2, 3, 4, 5, 6. Once again, I'm off the page. Go 1 unit over. That point should be right about there. If I wanted one point that's actually on the grid, what could I do? I could go 6 units up, 1, 2, 3, 4, 5, 6, and then 1 unit over to the left in the opposite direction. Notice my line is going down and to the right because I have a negative slope. Connect my points and it should be a really, really steep negative slope line. All right, we'll skip the boxes above. For now, we're going to just jump straight to the examples, example 2 here. So it says, write each point slope equation in slope-intercept form. Okay, so what am I giving you? Right now, I'm giving you an equation in the point slope format. I'm giving it to you in this format of y minus y1 is equal to m times x minus x1. Okay, that's what this equation above looks like, but I don't want that. I want it in slope-intercept form. And slope-intercept form is the one you guys are more familiar with. I want you to change this equation to make it look like y is equal to mx plus b. Okay, so here's all you got to do. If you want to change this format into this one down here, all you have to do is you have to get y by itself. You have to solve for y. Okay, so how am I going to do that? I see y plus 3 is equal to 3/2 times x plus 1. Okay, my goal here is to get y all by itself. The first thing I probably want to do here is I'd like to distribute this 3/2 to both the x and to the plus 1. Okay, so I'll rewrite it down here. On my left side, I'm still going to have y plus 3 because I haven't touched it yet. And on the right side, I'll see 3/2 times x, which is just 3/2 x. And then I'll see 3/2 times positive 1, which is just going to be positive 3/2. Okay, so I'm super, super close. All I got to do is I get y by itself. And the only thing that's next to y right now is that plus 3. So how do I get rid of a plus 3? I have to subtract 3 from both sides. So I subtract 3 from the left, and I also subtract 3 from the right. Now we got to combine like terms here. So I have to do, well, on my left side I'm going to have just y. The 3/2 x stays by itself. But 3/2 and minus 3 are like terms. How do I do 3/2 minus 3? It's the exact same thing. I'll do it off to the side here. 3/2 minus 6/2, get a common denominator. And this should equal -3. I'll do it down here. -3/2. -3/2 once you do 3/2 minus 3. And I'm in that format of y is equal to mx plus b. My slope is still 3/2, and I have to solve for my y-intercept of -3/2. We'll do one more. Okay. So I got y plus 6 is equal to -3 times x minus 4. Okay, I want to put it in slope-intercept form. I want it in the format y is equal to mx plus b. Same exact idea. I'm going to distribute -3 to both terms. -3 times x is -3x. And be careful here, -3 times -4 is going to be positive 12. On my left side, I still got y plus 6. I haven't touched it yet. And my end goal here is I just want to get y by itself. I have to subtract 6 from both sides. And what I'll have is I'll have just y on my left. That's exactly what I want. I still got negative 3x. And then 12 minus 6 is equal to positive 6. This is the equation in slope-intercept form.